So it's a binomial question from AIEEE 2004. In this question, it is given that Sn is equal to summation of from r to 0 to n 1 divided by ncr. Okay, and Tn is equal to summation from r equals to 0 to n r divided by ncr. Then we have to find the value of Tn by Sn. Okay, so suppose this is 1 and this is 2. Okay, so Sn can be written as 1 upon nc0 plus 1 upon ncn, nc1 plus 1 upon nc2 and so on up to 1 upon nc n minus 1 plus 1 upon ncn. Okay, so we know that the value of nc0 is 1 and ncn is also 1, so this is 2 plus, and now we know that the nc1 is equal to ncn minus 1, and similarly nc2 is equal to ncn minus 2, so we can say that it's the twice of 1 upon nc1 plus 1 upon nc2 plus and so on. Okay, so this is Sn. Okay, and suppose this is equation number 1 and equation number 3. Okay, this is equation number 3, and from equation number 2, okay, Tn can be written as 1 nc1 plus 2 nc2 plus 3 nc3 and so on up to n minus 1 nc minus 1 plus n ncn. Okay, so from this we know that the value of ncn is 1, so this is n, and also that nc1 is equal to ncn minus 1. Okay, as we have done previously for Sn. Okay, and if you add 1 divided by nc1 plus n minus 1 ncn minus 1 plus, similarly if you add 2 divided by nc2 plus n minus 2 divided by ncn minus 2 and so on, it will become n plus, this is n divided by nc1 plus 2 n divided by nc2 plus and so on. Okay, so if you take n common, you will have n plus n in bracket 1 divided by nc1 plus 1 divided by nc2 plus 1 divided by ncn and so on. Okay, and from equation number 3 we know that the value of this term is equal to Sn minus 2 divided by 2. Okay, so the value of this is equal to Sn minus 2 divided by 2. So if you put the value of this here, you will have Tn is equal to n plus n multiplied by Sn minus 2 divided by 2. Okay, so this is Sn multiplied by n divided by 2. So the value of Tn is equal to, so this is small t, okay, is equal to Sn multiplied by n by 2. Okay, so the value of Tn upon Sn is given by n by 2. So the value of Tn upon Sn is n by 2. Therefore option number 1 is correct.